about the One Water Academy. But for today, we are really pleased to have David Mullan from the Center for Transformation of Waste Technology speak to us about decentralized technologies, case studies specific to decentralized water reuse systems. I think our previous session was talking about water, drinking water, and sources of that. It was quite an interesting discussion after Dr. Sushant spoke. So now we're going to talk about wastewater reuse for decentralized operations. And the speaker is Mr. David Mullan. Mr. Mullan is by training an economist, and he has worked as a principal in a consulting engineering firm for over 3 decades, and then he spent the next decade as the director for the Center for Transformation of Waste Technology. So he has collectively over 40 years of experience specialized in the design, construction, and operation of decentralized wastewater treatment systems. David, all yours.
Thank you, Emmett. I appreciate the introduction. And for those of you who do not know, are not familiar with this center, it was formed about a dozen years ago with my late mentor, Dr. Jack Schaefer. Dr. Jack Schaefer met and became a very good friend of Prakash Tata, and Dr. Tata is now the executive director of this group. And we have been active for, like I say, since 2008 in this policy and water research and resource policy issue centered not-for-profit organization. And I've been involved with water most of my life in terms of the profession, so water became kind of my passion. Right now, as I shift gears from full-time water person, I've become involved with the Morton Arboretum, the worldwide famous arboretum who are the champion of trees, and I've become a professional tree hugger, and I work in prairies and woodlands to restore ecological systems. So that gives me a lot of outdoor experience in addition to the indoor experience I had with water management, and so I've become a person who enjoys water and land and trees. And so when we start our thought of how to plan for water resource management, we always start from a global perspective. And when you start from a global perspective and you look at our globe, it's a blue planet. And if we take all of the water on Earth and consider it as 100 drops, 97 of those drops are in the saltwater seas and oceans. 2% are captured in the polar ice caps, which leaves 1 drop of fresh water to support all terrestrial life on this planet. All human activity and all of nature must survive with 1 drop. So that tells us how precious water is. But the good news about water is that it is renewable resource. And it's not just the 1 drop that is renewable, it's the 98 drops that are not frozen in the seas that replenish our Earth. So water has always been a renewable resource. And that gives us a terrific advantage. We must always think of water as being renewed. There's no such thing as new water. The water has been reused for millennium. But what happens when we think about planning for the future is that we must take a look at how limited the water resource is relative to our growth. So if we have 6 million new people added to the earth every month, we must manage our water resources, our land resources, and our air resources in a smarter way. And we must think in terms of cycles. We must think in terms of the water cycle. We must think in terms of the carbon cycle. We must think in terms of the nutrient cycle. If we think of these things as cycles, we will start to integrate our thoughts with respect to land and water and air and begin to manage them in an integrated way. And when we manage them in an integrated way, what happens to our thought process when it comes to wastewater? Well, we turn wastewater upside down and say, wait a minute, wastewater is just nothing more than a pollutant that's in the wrong place. If it were in the right place, it would be a resource. So we coined the phrase, pollutants are resources out of place. The question is, how do you get them back to the right place? And that's what my dear colleague and late mentor, Dr. Jack Schaefer, started working on. He was a floodplain management expert, and he used to go into communities after a flooding and found that the sewage treatment plant was the first thing that became flooded because it was located down by the river. And you know what? It was the last thing that came back on as the flood receded. So the wastewater treatment plant operated for was shut down for the longest period of time. And Dr. Schaefer would ask the people, especially the people in Tennessee and other Tennessee Valley areas that were part of this early research in floodplain management, why did you put your wastewater treatment plant down by the river? Don't you know it gets flooded there? And they would say, well, Dr. Schaefer, you might have got a degree from the University of Chicago, but don't you know that water flows downhill? We have to have it down there because that's where the water flows. We have to treat it down there. Well, Dr. Schaefer doesn't just say, okay, that's fine. Dr. Schaefer said, what if there's a different way of thinking about what to do with the water? What if we turned it upside down? And then that's what he started doing with respect to water quality. He started turning things upside down. And what he found was if you leave the floodplain as open space, as vegetated open space, and don't put your floodplain as the site for a sewage treatment plant, but put the sewage treatment plant high and dry so it doesn't get flooded, then you can begin to think about irrigating the floodplain with reclaimed water. And from that simple thought, he started reinventing what he called wastewater reclamation and reuse. And that's what this schematic is all about. I'm not going to go into the details of this system, but one of the great factors of a successful system is its simplicity. And Dr. Schaefer worked really hard, and all of us helped him work really hard to make this a simple system. We have essentially three moving parts in our system. We have a grinder pump to bring the water in. We have to put the water under pressure because we send it to the bottom of a deep lagoon. We have an air blower that injects air, and this is an extended aeration system. That's our wastewater system, extended aeration. And we have an irrigation pump at the end to take the water out and put it on the fields. So essentially three moving parts. We make it as simple as possible. And the idea is that if you aerate for an extended period of time, you will benefit from the natural treatment processes of the aerobic and anaerobic system that we set up. So at the bottom of the pond, below where the submerged aerators are, we create an anaerobic zone where the solids are digested. And what that means is that we don't have any sludge to manage at the end of the train. We manage sludge first, not last. We also extend the concept of aeration. We don't think of aeration in terms of hours. We don't even think of it in terms of days. We think of it in terms of weeks. We give it weeks of aeration. And what that does is it creates a biological system that is very simple and very effective. And that's the basis of what happened with the whole approach of wastewater treatment in a decentralized system. But we didn't start out in a decentralized way. We started out with a massive program. In 1973, in the United States, Dr. Schaefer had just finished being the science advisor to the U.S. Department of the Army. He was essentially a major general, and he helped pass the Clean Water Act in 1970. The United States instituted its U.S. EPA, the Environmental Protection Agency, in 1972. And in 1973, the Muskegon County wastewater system was the first ever project funded by the U.S. EPA. It's U.S. EPA project number 1. And the reason they chose it was because it represents a departure from conventional thought. It involves the irrigation of 42 million gallons a day of water, a population equivalent in this case of almost 500,000 people. It's 420,000 population equivalent. And what happened was, this is a site on the Great Lakes, on the beautiful Lake Michigan, and very simply, all of these treatment plants from the cities and a huge amount of industry were polluting Muskegon Lake, which was a big lake feeding into Lake Michigan. And what Jack Schaefer decided to do was turn them all off. Bring all the water out away from the lake, treat it in a pre-treatment system, and store it in 2 great big lagoons. And then irrigate 8,000 acres, roughly 3,000 hectares of land. That was essentially an inland sand dune, not very productive farmland. But putting the nutrients back on the land in 1973 at a scale of urban management had never been done in this country. And so that's why this was called a land treatment system, and that's why it was considered as a new technology. That's why it was considered as a best management technology, and that's why the US EPA decided to call it its #1 project for demonstration purposes. We underdrain the project site. All the water is concentrated back and drops through a hydroelectric turbine, creating power to run the system. That water then flows through Muskegon Lake and out into Lake Michigan. And they thought it would take 8 or 10 years, maybe, to clean up Muskegon Lake, which is 7 miles long and 3 miles wide. It's a pretty good-sized body of water. But within 5 years, less than 5 years, the coho salmon came back from Lake Michigan into the heavily polluted Muskegon Lake, up the Muskegon River, and started spawning. So we knew we were successful because the fish told us we were successful. And that's one of the lessons that we learned. We have to pay attention to how nature responds to the way you manage water. And from this moment on, Dr. Schaefer thought, we'll be doing more municipalities. Well, Dr. Schaefer was only partially right. We had, immediately after this, the ability to work on a national flood insurance program where we all went out and did case studies, and then we all came back and started focusing on our water quality projects. And we got 2 phone calls, one from the biggest builder in the country, and one from one of the biggest residential builders in the Chicago area. And Jack was real excited. He thought, well, we're going to have big projects. But the answer was no. Mr. McHugh, who was the biggest builder of high-rise presidential towers and marina towers in the city of Chicago, award-winning high-rise residential projects, wanted us to take a small amount of his horse farm and convert it into a new community with conservation-minded approaches. And so what we did was we designed a little wastewater system that fit that concept. We take all the water from the houses, and we took all the houses that he was going to build and put them on just 40% of the land, and we saved the rest of the land as open space so that we could collect the water, reclaim it, and then irrigate a small portion of it so that there's no discharge from the site. We also did the same thing in the same thought process with stormwater and floodwater. We recreated a system of swales and detention basins and wetlands to store all the stormwater. Well, this site became a conservation mecca and won the Best in America Living Award for 1987 because of all of the conservations that went on. And then for Mr. Trammell Crow, who was a Dallas builder of the big office buildings. His problem was he had a site in Chicago he couldn't build on because the wastewater treatment plant nearby was at capacity and couldn't give anybody any more permits. It had a permit moratorium. There was no water connection to the site, and down the middle of the site was a big ugly ditch that during the rainstorms filled up with water. And he came to Jack Schaefer and he said, "What do I do?" And so what we did was, his idea was to build 4 million square feet of office space in a first-class hotel because he's right next to the airport. So what we did was, we reclaimed all the water from the buildings. We planned a wastewater system that would be a recycling system right on site. We dug down into the deep aquifer and brought up water and had 2 municipal water wells to support the development. And we created a series of lakes down the middle of the project to store all the stormwater. And we didn't just store the water that came off a 2-year storm or a 10-year storm. Dr. Schaefer took the regional storm, the 100-year storm, and made the storage work for that. So this became a no-discharge site, and the community didn't have to spend a nickel and got 4 million square feet of office space. And the builder, Mr. Trammell Crow, was really happy because he turned his ugly duckling of a site into one of the beautiful sites of the Chicago area. And he built his 4 million square feet and was really, really happy. Well, what did we learn from this lesson? We had a 420,000 population municipality, and then all of a sudden we had 2 small projects that both won awards. And so suddenly for us, small was beautiful. And that's one of the things that then turned our world upside down. We did a few more we did a few more big cities in partial completion. But from that moment on, we focused on decentralized wastewater systems. Wastewater systems that were built for small communities. And we did it for homes, for offices, for schools, for hospitals, for nursing homes, for resorts, for camps, for animal production facilities, for high-strength industries. We did it for correction facilities, and we did it for food processing plants, and we did it for golf communities. And I'm probably speaking to an audience that doesn't remember the great golfer Jack Nicklaus, world-famous golfer who ended up designing championship golf courses. Well, this is a community in Chicago that he designed, and he decided to use one of the Schaefer decentralized systems for its wastewater system. And so this championship golf course is in a community of about 2,000 people. And it recycles all of its water and puts it right back on the golf course. It doesn't discharge to anybody. And it's been in operation now for over 35 years. Mill Creek, and this is a picture of the golf course being irrigated. They don't often irrigate during the day. They mostly irrigate at night when the power costs are less. But in order to get a pretty picture with a rainbow in it, they had to take it during the day. So there's the championship golf course. There it is being irrigated. And this is another project that we did right to the west, another community that was a village scale of 900 people. And we did another project right next to, oh, excuse me, I missed it from, going the wrong way. There it is. The smallest community that we did was a 300 population equivalent community called Willowmere. And the reason this community became kind of special was that they wanted a soccer field. So instead of irrigating open space or a farm, they irrigated a soccer field. And the reason this community is fun to think about is that there was another community up north who at the same time, shortly afterwards, was considering one of the decentralized systems, but they weren't sure they wanted a process that recycled water and sprayed it right in their community. So they came down and looked at this one. This one became our demonstration community. And one or two of the people on the town board had children who were just of the age where they joined the soccer league. But the community didn't have a soccer field. It had to play all of its games away from the community because it had no soccer field inside the community. Well, what happened was when we went to the town meeting to consider approving a project at Woods Creek in the village of Wonder Lake, and this is a community of about 500 PE, so it's a small village. All the mothers were there with their kids. And the developer thought, well, we're going to get turned down because they're going to complain about the wastewater being recycled. But what happened was all the mothers and all the kids stood up and said, we want this development because our kids deserve a soccer field. We want a soccer field, and we want you to approve the water reclamation system because it will give our kids a home soccer field. So the town board voted unanimously to make this project happen. The home builder was really happy he got to build his homes. The town was really happy because they got to have clean water, and the kids were really happy because now they have a home soccer field to play on. And we learned the lesson that when you're planning a decentralized system, what you need to do is talk to the people. Go out and meet the people. What do they need? Do they need jobs? Do they need athletic fields? Do they need cricket fields in India? Maybe they need cricket fields in their villages. That's the way we became successful. And from that time on, we began to do small communities. So Kewanee, Indiana is a 1,000 population small town. Thompson Station is about 8,000 people. We did industries. ADL1 is a hog farm, a hog producer, so it's a producer of meat products. This is a small project in southern Indiana that needed to manage its water because it was in an area where it was just stone, and so they couldn't do anything with it. And we built a system for them, and we built a system for Motorola. This is an interesting system because we didn't build any wastewater system for this. We took secondary water from the existing treatment plant, brought it out to the Motorola plant, put it in a pond, aerated it, and Motorola uses it inside the building for in their purple pipes for gray water for their toilets. They use it for landscaping around. They use it as an evaporative pond on top for cooling purposes. They use this water aggressively in their plant. So this was another example of how reclaimed water was being used beneficially. In a high-strength industrial application, this is a chicken farm that produces eggs that wanted to have a new system. When they break the egg, they separated the white from the yolk so that they could manufacture products. But if they had big surges of very high BOD wastewater, and the high BOD wastewater comes in looking like sort of a brown syrup. And after our aeration, it turns into blue, clear irrigation water. And this solved their problem, and they were able to go from just producing eggs to producing all kinds of egg products. It gave them a whole new line of thinking. We even did one for a ski resort in Pennsylvania. We did a small project in Illinois. This is I think is a fascinating one. That's the clubhouse for a 9-hole golf course, public golf course. It could be a community center center in any village around. It could be a community center. It's got a few toilets, it's got some showers, and it's got a restaurant and a banquet facility, and that's all it's got. So the amount of wastewater coming to it on a daily basis is 5 cubic meters or less. And so what we did was we built a small pond, and we put planting around it, and this pond would fit basically in this room. I mean, it's not that big, but it solves the problem. And people came up to the owners, or the public park district, at a public meeting and said, "Thank you for putting a nice little pond next to the building. That was wonderful." And they didn't have the courage to say, "Well, the little pond is what we use to treat wastewater." So we decided small really is beautiful, and there's the answer. It's sitting right before you. And when we think about technology, we think about what I just said. We had 3 moving parts. Our grinder pump fits into a little box, and we bury it. The aerators are 2 little tubes size. It fits in a suitcase, and we bury it. And the irrigation pump is just like what you would find on most any golf courses. It's just a little irrigation pump. It fits in a suitcase. I could set the equipment on the stage here, and there would be plenty of room for all of you to come up and sit next to it. That's all the equipment that we needed to run this project. And it's been running for 12 or 15 years very successfully. We continued to do the idea of how to take land and make it productive. If you use land for recreation, you should also be thinking about how to store stormwater, harvest rainwater, recycle wastewater, and do other things, create wildlife habitats. A piece of ground should be something that you're proud of, and in communities, it can be a focal point for new jobs, new workplaces, and it can fulfill the goals of what you need. And the one I like best, which you wouldn't be surprised, there's the golf course. This is a forest irrigation project. Now, remember I said I became a sort of a tree hugger? This is located in northern Michigan, up by the Sleeping Bear Sand Dunes National Seashore on Lake Michigan. It's one of the world's treasure sites, and this is a resort right next to it, and it irrigates the woods right next to it, and it can irrigate all year long, because you can irrigate in the woods during the wintertime. So we can irrigate cropland and be productive, and we can irrigate golf courses and be beautiful, and we can irrigate forests and have a lovely resource for our community. So when we think about planning, we must think more than just water. We must think land, we must think air, we must think community needs, we must think what our children need. And so we must go through the process. We must think about how to treat the point source pollution in a lake that fits the community. We must think about non-point source pollution in swales that convey the water slowly off the site, and during the flood store the water so that your neighbor downstream is not flooded. We can store the water on a golf course. This is an actual flood on one of the golf courses that we built, and it's storing the water. We can store the water in a big lake. Oops. Or we can use the water as a farm. This is a farm that's very interesting because it's a retirement community. It's an affordable retirement community. Everybody there gets a very inexpensive, well-built modular home. You might call it a trailer, and it's an area where keeping costs low are critical. So they decided to go with a farm because they can sell the hay that they grow and the other crops, and offset the cost of their wastewater treatment system and keep the cost of water low for the elderly residents of their community. And we always brag about the fact that if you irrigate with reclaimed water, you're recycling nutrients. And so we increase productivity, and we get more agricultural benefits. And we sequester carbon. And we create greenways. And we build better communities. I was going to bring one of my associates with me, the assistant wastewater operator, but I realized I couldn't get him a permit visa. They wouldn't approve the visa. Oh, there he is, right there. He's the duck floating there. There's two of them. Why do I say that? What is the linkage here? Well, in our systems, aeration, extended aeration is everything. The ducks come to a pond that's being aerated or that has been aerated. A fully aerated pond will attract a duck. A duck likes to bobble in the water when it's being aerated. If you look out your window and you say, "Where are the ducks?" There are no ducks here. You would better check your aerator because it's probably off. And so our duck is our assistant aeration operator. All we have to do is say, the ducks are there, the aeration is working. The ducks aren't there, go fix it. So from a low-tech point of view, you don't need instruments, you don't need meters, you don't need anything like that. If you pay attention to the fact that the fish told us how successful Muskegon was, and the ducks tell us how successful our aeration was. On that basis, I will leave you with a thought. Meeting the challenges of 600,000 villages in India, manage the environment in harmony with nature, and the project will be successful. And with that, I will leave you. Thank you very much.
All right.